So before we start, just give me a moment. Give me one moment. All right. Sorry about that. I was just looking at my notes. Okay, so hello everyone, and today you are with us for a discussion on Terraform, right? We are going to understand what is Terraform, right? So what is it? Why do we use it? And then we'll talk about how do we use it with a demo. All right. Hopefully my screen is legible. You can understand what I'm writing. And before we start, a brief introduction about me. My name is Amit. I am based out of Bangalore, India. And I have around 19 years of experience in the industry. So I have worked with almost all the DevOps technologies, version control systems, configuration management systems, CI, CD, deployments, Kubernetes, cloud environments, so almost everything. So today we are going to talk about what is Terraform, what is it, why do we need it, and how does it work? Okay, pretty simple. We are going to have it um, for 1 hour. The session is for 1 hour. I'm going to talk till 3:45, so like 40 minutes talk, and then we will have some questions. Okay, so now let's start. Right. First of all, let's understand the need of Terraform. So let's say you have a team of few people. You have a team of few people and you require infrastructure resources. So what do? You go to your cloud account, let's say AWS. You go to your cloud account and create the resources that you need, right? You may need some, let's say VMs, some storages, some other managed services, databases, whatever, right? So you can create some VMs, some disk, some databases, whatever you need can be created here. And then you can continue with your work, right? Now, let's say you want to save some money, right? There is no data, persistent data stored on the VMs. So what you want to do is every day when you come to office, you want to power them on every evening when you leave office, you want to power them off so that you can save a bit of money, right? This is a good idea. But then somebody has to do this, right? Somebody has to come to the office in the morning and then click on bunch of links, fill in some bit of forms, and then create the instance or write some commands, CLI commands to create the power on the VMs and then power off, right? Also, you want to ensure that whatever resources you create, you document them, right? So there is a list of which resources are created, what is their configurations, in which account they are, and things like that, right? So although it is possible to do manually, but then there is a limit at which it will stop scaling. You hire more people to perform these tasks, or you find some other way to do it. Otherwise, it's going to take a lot of time just to do this, switch on and switch off. Also, there could be a use case that similar infrastructure is required by other teams. right? Other teams want to have a same infrastructure. Now, they also can manually create the infrastructure, but how do they know that it is exactly same as theirs, right? So to solve these problems, we have a concept called infrastructure as code. Infra as code. And what it essentially does is, instead of manually creating the infrastructure, you use a tool. It could be any tool. There are many tools available for that. So we use a tool, which is an ISE tool. And instead of manually creating infrastructure, we write a bit of a configuration, which is our desired infrastructure. So desired configuration, it is written in this file, right? It is written in a file, and then it is fed to this tool. These tools are ISE tool or configuration management tools, right? It could be Terraform, it could be Cloud Formation, it could be Azure Resource templates, or it could be anything. And when you write a configuration, feed it to this tool is going to talk to the cloud provider. This tool talks to the cloud provider and then creates the infrastructure for you. Okay, so you don't go to the cloud provider, or I would say, let's say here is a developer who writes the configuration, feeds it to Terraform, and then cloud provider is contacted by Terraform and the infrastructure is created. The user will not directly go to the cloud provider and create the infrastructure. No. So the advantage of writing code and then creating infrastructure is this entire infrastructure becomes repeatable. That means you give this code, you give this to Terraform and create one more set of infrastructure, right? It's a piece of code. You apply it on another cloud account, right? Or you apply it on a different cloud provider also. So you can repeat the same code to reproduce your infrastructure. Also, it is reproducible. What does that mean? That means if for some reason this infrastructure dies, then if you run this command again, run the Terraform again with your code, the Terraform will be brought back up again with the same exact configurations, right? So the infrastructure becomes repeatable, it becomes reproducible. You can also track the changes to the infrastructure because this file could be put in a version control system like Git or any other version control system. And then you give access to certain people, people make changes to this file, go to the Terraform, update the infrastructure, and then you can track who is making infrastructure changes. Right? So you can track your infrastructure. And this document also this code also acts as a document, right? What exists in your infrastructure, how many VMs, how much data disks, how much database, what is the size of the database, what is the connectivity, what are the firewall rules, everything is documented in this code. And that is the reason why we use infrastructure as code and how Terraform helps us in achieving this. Make sense? Let's see an example. So how do we set it up? First, we will set it up and then use it. So setting it up, it is pretty easy. You need to have a Terraform control machine. We need to have a Terraform control machine. All right, sorry, it took time. So you take a machine, right? It could be a Linux machine, it could be a Windows machine or Mac, whatever. You need to install a tool called Terraform. Terraform core. And then you write some configurations, right? Could be simple configuration that I want a EC2 instance, I want a RDB MS, I want an S3 bucket, whatever. You can write your requirements, feed it to Terraform, and what Terraform is going to do is it's going to talk to your cloud provider, let's say AWS for discussion, and it will talk to cloud provider and create an infrastructure for you, right? The only thing that you need to do is you need to tell Terraform your credentials so that it can talk to your cloud account, right? So you need to give it some credentials. So in the configuration code, you can specify credentials also. Or you can provide it outside in the system. Some way, there are multiple ways. You have to pass credentials to the Terraform core, and then Terraform is going to take the help of, well, I'll come back to that, but then Terraform is going to talk to AWS and create the infrastructure. Okay, let me show you how you can set it up. So I have a cloud account. Just give me a second. So I have an AWS account. I'm going to log into it. And this is my AWS account. You might have seen AWS account before. If you're new to AWS, then I think you need to learn AWS a bit. But this is the landing page of AWS. And you have different links, which takes you to different services. And then you can create your resources on those services. Let's say I want to create an S3 bucket. Right? Pretty straightforward. Let's say I want to create an S3 bucket. Generally, what do? I go to S3 and I click on create bucket and I give some details and the bucket is created. But that's not what I want to do. I want to write a code to create an S3 bucket, right? So I need a control machine. This is a control machine or a control server, Terraform control server. That means I write all my Terraform code on this machine. I need this machine so I can use my Windows laptop as that machine, right? So I can do this. Yeah, so this is my laptop and wait a second. Let's say I create this directly, right? I'll put all my code here. So I'll put my code in this directory. Before writing my Terraform code, I need to have Terraform installed. Now I have already Terraform installed on this laptop. Oh, I don't. Terraform. I don't have it. So let's install it. To install Terraform, let's go to the Terraform official installation guide. Right? Just look for HashiCorp Terraform. HashiCorp is a company that makes Terraform. So look for Terraform installation guide. It will send you to this link, and you can go to Chocolati on Windows and follow this installation. Okay, on Windows, it's not straightforward, right? On Mac, it is pretty straightforward. On manually, you can also actually download it. Yeah, but it's not very straightforward for Windows, right? So I'm going to see if I can use this command. It requires a tool called Choco or Chocolati installed on Windows. But since I may have it already, I will just use it if it works. Otherwise, we'll find some other way. Okay, I don't have Choco. What do we do now? So now let's create a new VM for us. So manually, I'm going to create a VM on EC2 instance, and EC2 instance I'll create, and I'll use that as control machine. I'll create an Ubuntu machine with default values. And I'm going to edit this, and I'll say all traffic should be allowed, and that's it. Okay, so instance is created. This is my control machine, and I will connect to it once it powers on. Done, right? So I'm connected to that machine. This is my Terraform instance, Terraform control machine, right? Now on this machine, I'm going to install Terraform. Let's again go back to the installation guide. And this time I'm going to choose Linux and Ubuntu. And there are a few commands that I need to run. So I'll just copy this command and run here. Then I'm going to copy the next command. Run here. Then I copy this one. This is just a verification command, should be okay. And this is going to add a aptitude repository. You see, it adds this URL from where now Ubuntu can download packages. So all HashiCorp products are in this URL, in this repository. So we added that. Then we get the list of all the packages available in this repository. So that's what it's going to do. It talks to the URL, gets the information. So this is standard Linux management. Okay. And then we have this one. And now Terraform is available. If I run this command, I will get some output. Okay, cool. Terraform is up. Now, what is my requirement? I want to create an S3 bucket, right? So first thing is, when the Terraform is done, I need to identify where I'm going to write my code, one directory. So I say This is my directory, tf demo. I'm going to write my code in this. The first thing that we need to do is now Terraform actually cannot directly talk to the cloud provider, right? Terraform can understand the code and it can instruct the cloud provider on what to do, but to talk to cloud provider, it needs to speak the same language. So the AWS expects configuration in certain format. Terraform will need to will need to give the instructions in that format, right? And that is enabled by something called as a provider. Provider, right? This is a plugin that means an external binary that you download and install. And this is called a provider. So we have provider for AWS, we have provider for Azure, we have provider for Google Cloud, for many other cloud providers. So Terraform is going to understand this configuration. It's going to talk to cloud provider to pass on the instruction to AWS. Okay, with the provider, it speaks the same language as the cloud provider, right? So now, first thing that we need to do is we need to use a proper provider. We need to tell Terraform to use a proper provider. And for AWS, it is AWS provider. Now, how do I get it? How do I install it? So let's go to Terraform providers. If I look for Terraform providers, the first link is a link for a service called Terraform registry. This is where Terraform stores all its providers and other shareable binaries or artifacts. So we have the providers here, and the first one is AWS. Let's take it. And I'm going to take you through a bit more on this, but right now we want to use this provider. So it says, just write this code in your Terraform file, and you are done. Just this code, right? Cool. So I'm going to create a file. I will call it as main.tf. Now, any Terraform code that you write, which you want Terraform to understand, has to end with the extension .tf. .tf is the default extension for Terraform code. Okay, so main.tf, and we are going to write this code here. Now, this is a special language. It is something like JSON, but not actually JSON. It's a similar language as JSON. It is called HashiCorp configuration language. Now you can read more about it, or in the future sessions, I can cover this. But this is what we write. Okay. Here we are specifying that we have a Terraform configuration, like these are the required providers for this code. And we need a provider which is called AWS. This is the source, and this is a version that we want. And for any configurations of this provider, any settings and all, we will provide in this provider block, right? Save it. I save it. And if I say, now I need to install this provider, right? So Terraform init. Init is a command which initializes your code directory. So this is a directory I created, and I plan to write my Terraform code here. So running Terraform init is going to prepare this directory to accept Terraform code. So right now, as part of initialization, it is going to initialize a provider plugin. It saw that there is a code for AWS provider. It's going to download it and install it. And done. Now you will see in my current directory, there is a file called .terraform. And inside this .terraform directory, there will be a provider. Let me list the directory structure. There is a very nice utility called tree, which allows us to print the complete directory infrastructure. like this. So tree dash A, it will print all the files in all the directories. So you can see here, I just created main.tf. When I did Terraform init, it created this file, and inside all these subdirectories, this is my binary, the provider. All right. That is how we set up the provider. So now we have Terraform code. We have the provider. We will write configuration. We need to define the credentials. Okay. So we need to define how is Terraform going to talk to AWS. Right. So that's the last thing remained for the setup. So for that, if we go to the documentation for Terraform registry AWS, if you go to the documentation, it starts with examples, right? And then this also tells us about authentication and configuration, how we can authenticate to our cloud provider. So there are many various ways. There are actually 6 ways you can authenticate against AWS. First is you write your parameters in provider configuration. That means in the code itself, you remember provider block, which is part of the main.tf. There is a provider block, which we copied as part of documentation. In the provider block, we can define which region we want to work as, what is the access key, what is the secret key, and we can give it here. It is pretty insecure because the credentials are then saved in the file, but it is okay for demonstration and all. Next is you can set environment variables, and Terraform is going to pick up from that. Next is you can have that AWS config file where you can have your credentials, right? So you can create credentials here, or you can have container credentials. So if you are running on some container environment, we can add the credentials, or there are many other ways. Okay. So what I'm going to do is I'm going to go fall back to the most insecure, but the easiest one to implement, which is the configuration file. So in the configuration file, I'm going to paste this configuration. And now I want to use US East 1 as my region. And then I need to give the access key and secret key. I cannot give my username password for the AWS account. I need to generate API keys to provide here, access keys. So if you are familiar with AWS, you can go to your AWS account. In the services, search for IAM, which is Identity and Access Management. And here, go to users, go to your user account, go to security credentials, scroll down, find access keys, create access key, command line interface, and understand and create key. So now you get an access key and secret key. This is what we are going to use in our code. Now again, this is very sensitive information. I'm going to delete these keys very soon. So even if you try to remember them, you won't be able to do much. But I trust you guys. Okay, so we copy this and here we go. So now Terraform knows which provider to use, and Terraform knows what access permissions or access credentials to use to connect to my account. Done. Right? Okay, let's do Terraform init once more, although it is not required, everything exists. Should not take this much time. All right, everything is good. Now what to do? Now we write our code. So I'm going to write, let's say, my S3 bucket.pf. Now file name can be anything. but it has to end in .tf. The file name does not matter. It has no significance. Okay, I cleared this. I want to create an S3 bucket. So let me write a small code. I'll say resource AWS S3 bucket. Let's call it as my S3 bucket. And let's say bucket equal to, let's give it some name like this. Resource AWS S3 bucket, my S3 bucket. And this is a piece of code. It is similar. It is in HashiCorp configuration language. Now what it does is it tells Terraform to create a resource on the cloud provider. The type of resource is this, and this is the type of resource. The name of the resource is this within Terraform. And then I want to create the bucket with the bucket name this. If I don't provide the bucket name, then it will be automatically generated by AWS for us. A unique name will be generated. Right? That's it. So I have my code. So I have this code now ready for S3. I have provided my credentials. Provider is installed. So now Terraform is ready to serve us. I said Terraform plan. What Terraform is going to do is it's going to tell us what is its plan, what is the plan of Terraform to get us this configuration, right? What are the things it's going to do? Is it going to create anything? It's going to delete anything? It's going to modify anything? Let's see that. So Terraform talks to cloud provider and it will see that there is a configuration. There is no bucket existing with the same configuration on AWS cloud. So it says that this is the plan. Terraform is going to perform these actions. AWS S3 bucket, this bucket will be created with these details. I could have provided all these details, but they're all optional. But I did provide the detail called bucket, which is the name of the bucket, right? So I'm happy with this plan. I'm going to say Terraform apply. And this command is going to apply the plan, run the plan, execute the plan. I have to confirm that yes, I want to apply. It says specified bucket is not valid, invalid bucket name. And that might be because it has capital letters. Okay, let's plan again. And it gives me the output that this bucket is done, created. If I go to my cloud services, I go to S3. You see there's a bucket here. So now, just with writing one code, I can get right. Just writing with one code, one piece of code, I can get my resources. Right? I can also get a virtual machine, a complete virtual machine. Let me show you. Let's create another file. And I will just copy paste my notes. So I create a resource like this. Resource type is AWS instance, which is EC2 instance. This is a name uh, with which Terraform can refer to it. Instance type is T2 micro. And AMI, which is the OS image, is this one. This is the ID of the AMI to use. I need to specify what is the instance type and what is the AMI ID so that it picks up the correct things. And these are kind of mandatory options for the resource. So now with this, let me rename to TF. Right? We need it with the name TF. Now I'm going to say Terraform plan. Show me the plan. The Terraform says for the configuration that we have provided to get the infrastructure, it will need to perform this action. This EC201 will be created. Please note, it does not tell anything about S3 because it sees that there is a configuration for S3 bucket and already an S3 bucket exists, right? So nothing required there. Only EC2 instance is required, right? I'm happy with the plan. I say apply. And very soon you will see that if I go to EC2, there is a new instance being created. It's in pending state, but very soon it's going to be running. And done. Terraform has confirmed that it has created our resources. So now I have this code and I can, while going in the evening, I can just say Terraform destroy my whole infrastructure. Terraform destroy, right? So destroy my whole infrastructure. There could be 100 VMs, 100 S3 buckets, destroy everything. And when you run the destroy, it shows me the plan. It says when I'm destroying the things that this instance will be destroyed and this S3 bucket will be destroyed. So yes, bucket is deleted, EC2 instance will be destroyed. And tomorrow morning, I come back to office and I can say Terraform apply and create the entire infrastructure again. Now there's a question, how can we attach a key with the help of Terraform for a VM? So if you have existing key pairs, then let's look at the documentation, right? So this Terraform provider has excellent documentation. Let's look for instance. So if I go to EC2 AWS instance, there's a documentation, lot of documentation. Let's see the argument reference. And here you can see key. You can specify the name of the key which you want to associate with the VM. You can also create a key pair from Terraform. So you can write a resource like this, resource AWS key pair, and the key name and the public key. Or you can get the public key from the file. Okay. All right. Another question is for the state file. So if you see here, we have a file called tf state. What does that mean? So Terraform state file is a very special file which is created by Terraform. Whenever you apply a configuration, it makes the infrastructure changes and then it stores that infrastructure. Just 1 second. Sorry about that. So whenever Terraform creates a resource or updates a resource or manages the resources on cloud provider, it stores the information about those resources in a file called state file, right? So if I write a configuration for S3 and EC2 and then apply those resources on AWS, once the application is done, Terraform is going to remember that EC2 instance was created, what is the ID, what is the region, what is other information. Okay. And if S3 is created, so what is the name, what is the region, and every information. So state file is important for that. And whenever you do a Terraform plan or apply, Terraform is going to verify if the state file already contains that resource. If it doesn't, then only it creates the resources, right? So let's go back here. If you see the state file, terraform.tf state, you will see it has information about, well, right now we deleted all the resources, so it doesn't have information about any resource, but it does have, it stores information about the resources in JSON format. Okay, so now officially let's open the Q&A floor. That's all I wanted to talk about. You will get the recording of this session whenever it's available. Is it possible to retain the data that we had in the resource? If you had mounted an external disk, then yes, you will have the resource data. Can we integrate the Linux code Windows with some tools like Visual Studio? Because this question is like Linux code Windows with some tools. You mean Terraform? Yes, you can use Visual Studio with Terraform. Can we destroy partial infrastructure? Yes. So when you do a destroy, you can say target and specify that I want to destroy an AWS S3 bucket dot my bucket or something like this. So then this action like destroy or apply will only target this particular infrastructure. It is not recommended to do because it brings in a lot of inconsistencies. But if there is no other option, then you can do that. See, Terraform does not care about your data. If you have data on a VM or on a database or on an EBS volume, it is your responsibility to manage the data. Either you set up backups or you take snapshots, whatever. If you destroy from Terraform, it's going to destroy it. So it should be your strategy on how do you preserve the data. Okay, data is always your responsibility. If you have multiple TF configurations, can we expect the configuration to be taken by Terraform? No, Terraform is going to go through all Terraform.tf files and consider all of them. If resource is deleted, let's say S3 bucket directly on the UI, and then you add an EC2 instance and then run Terraform plan, what will happen? Will it match with the state in local? No, it will say that there is a missing infrastructure on the UI. It is going to recreate it. What would happen if I delete the state file after apply? If you delete, that's a good question. If you apply, let's say you create an EC2 and S3, which is saved in the state file, and then you delete the state file, then Terraform is going to think that there is no configuration or no infrastructure on the cloud provider because state file is empty. So it's going to recreate the resources. So you will have duplicate resources. Okay, more questions. Terraform documentation link. All right. Okay. So you mean, I think you mean the provider documentation. This is the one. I'll share it with everyone here. Can we create Azure function? Yes, of course. With Azure Provider, you can create Azure functions. Can we code for RBAC, VNet, hardening of a VM? Hardening of a VM will be on the operating system, right? Whatever is in the scope of AWS or Azure or any other cloud provider, you can do that. But if you want to harden the operating system, then you have to use something else like Ansible. Can we add multiple provider in one file? Yes, in one .tf file, you can have multiple resources. Terraform is a centralized control monitoring tool for cloud infrastructure. I'm not sure why you're mentioning monitoring tool. It's not a monitoring tool. It's an infrastructure configuration management tool. You can use it as centralized or you can use it as at individual machines as well. How Ansible is different from Terraform. So Terraform is used to create infrastructure and Ansible is used to configure servers when you have operating system running. Okay, so Terraform is going to give you server with an operating system thanks to the cloud provider. And then Ansible can be used to configure that infrastructure with your desired tools, user accounts, files, services, whatever. What do you think about using Terraform along with TerraGrunt? TerraGrunt, okay, this is something new. Is it the fork of Terraform? TerraGrunt. TerraGrunt is Terraform wrapper. Oh, okay. Yeah. With the definition, it looks nice, right? I may use it, but I will have to read about it. But thanks for this. This is something new which I learned. Can we create Azure function? Yeah, you can. How to prevent VMs being rebuilt with old image? New image issued with latest patches, but Terraform file specified old image, which is insecure. Then you should update your Terraform code. That is the excellent use case. If you know where is the problem, just update your code and apply it. It's going to be rebuilt. Is there any option to delete the S3 bucket even though S3 have contents? Uh, I'm not sure what are the AWS policies, but I think it doesn't allow you to delete with content. So you need to first empty it up. But there are some flags you can specify that you should be allowed to delete S3 bucket, but I'm not sure. Can we execute shell script? No, you cannot. For that, use Ansible. You can use what EC2 provides, which is user data. You can provide that. But yeah, you can also use provisioners, but that is highly, highly not recommended. Provisioners are ways to connect to remote machine and then run some commands, but nobody recommends that. Can we say Terraform as alternative tool of Ansible, Shell, Python? Not exactly. It has a different use case. It is very similar to Ansible, but use case is different. So, but yes, you should be able to run these commands with your current license, of course. How do we scale in and scale out VM operations? If you want to manage the VMs at scale, you should use scale sets. So please do that, or auto scaling group. What do you mean by Terraform refresh? Terraform refresh is a command which allows you to refresh the data of existing resources if something has changed on AWS. For example, if there is an EC2 instance running for which there is also state file available or state information available, and somebody modifies the EC2 instance with that, if they change the type or if they update the tag, yeah, some modification is done, then Terraform refresh is going to compare the configuration available in the infrastructure with the configuration available in the state file. And if there is any difference, it's going to update the state file with what is there on the infrastructure. So Kanmani, it will say that your VM will have to be reverted to RHEL 8.8 because the AMI ID will be different. What is the most cost-effective method for learning Terraform with the AWS provider? Create a free tier AWS account and just start writing code. You don't have to pay anything. If the provider is not listed under Terraform, can we build code to make it compatible for the new provider? You can write your own providers also. Yes. Terraform module is a separate concept where you write your code and share it with others. You write reshareable or shareable code, but not enough time today. Can you run destroy command? Is it only delete Terraform, create resources, or delete existing AWS resources? You cannot delete AWS resources using Terraform if they are not managed by Terraform. If you run Terraform apply, Terraform is not going to recreate your resources. It will say that resources already exist. Okay. All right. So thank you so much. It was a pretty quick session just to get you a brief understanding of Terraform. I hope you liked it. We have more sessions like this, so I encourage you guys to participate in those sessions. You will receive recording of this as well as soon as it is available with the skill of right. Yeah. Thank you. Have a good day. Bye.